Hello. In this lesson, I want you to evaluate and rewrite expressions involving rational exponents and solve equations involving expressions with rational exponents. Some vocabulary you're going to come across is rational exponent, cube root, nth root, and exponential equation. A rational exponent is an exponent that's a fraction. That's all it means. If I have the nth root of b, I'm going to write that as 1 over n. N is my index. Now, the one thing to remember, if you don't have an index, it means square root. So if I have the square root of b, I write that as 1 over 2. Without writing the index, I know that's a 2 because you can't take a root 1. So square root means 1/2. Anything else, we're going to have a number for. So on our next problem, or on these examples here, I'm going to write each expression in radical form or write it in an exponential form if it's already in radical form. So if I take a look at 1, here's what I'm talking about. My index is 2, so I don't write it. It's just the square root of 25. That's the answer. I could simplify this to 5. That's all you have to do. Let's take a look at the square root of 18. So I'm going to write 18. The index is 2, so I'll say 1 over 2, 18 to the 1/2 power. On example 3, notice I'm not in parentheses, so I don't do anything with the 5. The 5 stays as 5, so I have 5 times the square root of x. If the 5 was in parentheses, then they both would be inside the radical sign, but in this case, that's what we have to do. And then, on example 4, here's what I'm talking about. 8 and p are both inside the radical sign. So I'm going to say 8p to the 1/2 power. Now we're going to actually simplify. If I have the cube root of 27, when you make a factor tree, instead of doing it twice for square root, we make it 3 times for cube root. Here's what I'm talking about. So first I make a factor tree. What goes into 27? Well, that's going to be the cube root of 9 times the cube root of 3. Well, the cube root of 9 times 3, sorry about that. Yeah, 9 times 3 is 27. And then the cube root of 3, a cube root of 9 is a cube root of 3 times the cube root of 3. So what happens here, I've got the cube root of 3 times. Which means I've got the cube root of 3 cubed. They undo each other, so my answer is just plain old 3. I have to have that many numbers to simplify it. So let's take a look at example 6. So in other words, if I have the 5th root, I have to have 5 of these in order to write it once without the radical sign. So I'm going to start here. The cube root, not the cube root, sorry, the 5th root of 32 times, whoops, not 32. 32 is my problem. I'm going to say 2 times the 5th root of 16. Sorry about that. Try that again. Can't write very well here. Let's see if I make it a little bit thinner here. So I've got the cube root of, why do I keep on saying cube root? Because I'm on the last problem. The cube root of 2, 5th root of 2, times the 5th root of 16. Then I'll say the 5th root of 8 times the 5th root of 2. I'll say the 5th root of 2 times the 5th root of 4. And then I'll break 4 down, and that'll be the 5th root of 2 times the 5th root of 2. We just do a bunch of factoring here. Now, if I count here, I've got 1, 2, 3, 4, 5. So in other words, I've got the 5th root of 2 5 times. So I can write that as the 5th root of 2 to the 5th. They undo each other. Your answer is 2. So the 5th root of 32 is 2. Let's take a look at number 7. Now, that's in fractional form. So what does that mean? Well, that means I'm going to do the cubed root of 125. I like to do it with radicals. You could make a factor tree, I guess, with the fractions too. And so we could say that'll be the 5th root, or the 5th root, sorry, cube root. Keep on doing the wrong problem. The cube root of 5 times the cube root of 25. And the cube root of 25 is a cube root of 5 times the cube root of 5. And then, so I get the cube root of 5 times the cube root of 5 times the cube root of 5, which is the cube root of 5 to the 3rd. What do I put 5 there? Darn it, cube root. Sorry about that. And you get 5. Now, could I have done this without my radicals? Sure, I could have. What I could have done here, just to show you, it's the same thing. If I take 125 to the 1/3 power, I'll still make my factor tree. I will say 5 to the 1/3 times 25 to the 1/3. And then 25 to the 1/3 is 5 to the 1/3 times 5 to the 1/3. So I've got 5 to the 1/3. I'm doing that 3 times. Power of power, we multiply the exponent, you get 5 to the 1st. No matter how you do it, you get 5 for an answer on this problem.